Hey everyone, welcome back. Today we are diving deep into the mysteries of our universe past. We often think we know how the universe works Big Bang, galaxies, black holes. But for thousands of years, humans look up at the sky, uh, exact same sky, and saw something completely different. From the cyclic time of India to the cosmic egg of China and the crystal spheres of Greece. Today, I am going to tell you the story of how we tried to find our place in the stars. Let's revive. Our story it starts in the cradle of civilization, Babylon and Egypt. The civilization were master observers. They created detailed star charts and very first calendars, but they had one major limitation. They believed Earth was the center of everything. They believed on geocentric model. To them, the sky was a dome and we were the stage. Now, let's travel to Asia. In ancient India, cosmology wasn't just science, it was philosophy. While the West often viewed time as a straight line, start to finish. Indian cosmology, influenced by Hindu, Jain, and Buddhist thought, say time as a circle. The universe undergoes endless cycles of creations and destructions, measured in vast periods called yugas and kalpas. Let's break this down into eras. First, the Vedic era, 1500 BCE. They developed the nakshatra system, 27 or 28 lunar mansions to track the moon. It was astronomy perfectly blended with religious rituals. Second is the Siddhantic era from 5th to 12th century CE. This was the golden age. They moved from mythology to hard maths. Meet the genius of this era, Aryabhatta, 5th century. In his work, long before modern science, he wrote the Aryabhatta. He proposed that Earth rotates on its axis and correctly explained that the moon and the planets do not have their own light. They shine by reflecting sunlight. He also calculated Earth's circumference with crazy accuracy. You can imagine at that time he calculated accurate circumference of Earth. The next personality is Brahmagupta from 7th century. In his book Brahmagupta Siddhanta, he gave us zero as a number and stated clearly that the earth is a spherical. Next personality is Bhaskara too from that time, 12th century. An author of the Siddhanta ceremony, he touched on the concept of gravity and velocity centuries ahead of Isaac Newton. Meanwhile, in China, astronomy was serious business, literally life or death. It was deeply tied to politics, and eclipse wasn't just a shadow, it was an omen for an emperor. Chinese cosmology focused on Qi. Qi means energy. The Taoist principle divides this energy into Yin, dark and passive, and Yang, bright and active. If we simply say the Qi means energy, and this is two types, Yin and Yang. Yin means dark or passive, and Yang means bright and active. You can now understood it better. The universe was seen as an organism, alive and dynamic. They developed three fascinating models. First is Gaitian. Gaetian means the canopy. Imagine a square earth surrounded by water with a round sky covering like a lid or canopy. They believed the heavens rotated around the central north pole like a giant umbrella spreading over the world. Next theory is Pian, the cosmic egg, which we know. This was the most accepted view. The universe is like an egg. The earth is the yolk suspended in the center, and the sky is the cell. The next one is Zun-Ye. Zun-Ye means infinite empty space. This is mind blowing. They suggest that heavens were the infinite and empty, with stars floating freely. No cells, no domes, just void. Just like today. Grace theories, just like grace. Yes, we can say. Now, let's come to Greece. Enter Aristotle. In his famous book on the heavens, De Calio, he built a model that defined Western science for nearly 2000 years. He argued that the earth is a stationary sphere at the center of the universe. He proved the earth was round with three key arguments. The first argument is the eclipse argument. During a lunar eclipse, the earth's shadow on the moon is always curved. Only a sphere casts a perfectly round shadow every time. This was the major argument given on the proof that earth is round. The second argument is the pole star argument. As travelers moved south, like from Greece to Egypt, the North Star appeared lower in the sky. If Earth were flat, the star would look the same height everywhere. The other argument is the ship argument. When a ship sails away, the hull disappears first and the sails disappear last, providing that the water curves. But there was a problem. Yes, there was a problem. Planets sometimes look like they moved backward in the sky. Retrograde motions, you can say. Aristotle's perfect circles couldn't explain that. Enter Claudius Ptolemy. He fixed the math with a complex trick called epicycles. He said planets move in small circles which ride along larger circles. It was like a Ferris wheel attached to another Ferris wheel. It was complicated, but it worked for predictions. So, humanity stuck with this geocentric model for over 1,000 years. So, for millennia, we were the center of the universe. We felt special. We felt stationary. But we were wrong. Before I go, I have a question for you. Which ancient model was your favorite? The infinite void of China or the cyclic time of India? Let me know in the comments. Next time, we are going to break the glass spheres. We will talk about the rebels who dared to say the earth moves. Get ready for the Nicholas Copernicus, Tycho Brahe, Johannes Kepler, and Galileo Galilei. Don't forget to like and subscribe for part 2. Thanks for watching.